Today's topic is KUKA Advanced Welding Solution. And with that, we actually are talking about mainly two types of solid state welding. But of course, most of you relate to KUKA as a robot supplier. And we have been starting to use a slogan, if you like, which we call More Than Robots. And with that, we mean that, of course, we have probably the market's widest range of robot types. But a robot program is so much more than just robots. It's all the softwares and the functionalities around them. But less known is that KUKA is also a world-leading supplier and has been this for decades of solid-state welding solution. And two of the main types of solid-state welding we supply is, for the first, it's friction stir welding, where we can supply standard cells or complete turnkey projects for friction stir welding. And the other main type we supply is actually rotary friction welding machines, complete machines. So here, KUKA is actually a machine builder and not a robot supplier in this aspect. And some of you may know the brand KUKA for rotary friction welding machines, but also Thompson, which is a part of KUKA as well, because we already today have a large installed base worldwide of these types of machines. So what are these technologies? Well, let's dive into them a little bit deeper. There are some common factors between both these two types of friction stir welding and rotary friction welding machines. Why do we use friction welding at all? Well, one very large and important part is that with friction welds, there are no consumables required. We are only joining two materials without adding any exterior material in any way. No filler, no inert gas, nothing. We're just using the materials we want to bond. And speaking of bonds, with friction welding, we get a complete homogeneous bond across the entire joint surface, not only where we normally otherwise would have added a filler, we get a complete and homogeneous bond. And friction welding has another nice effect, and that is that it allows us to join dissimilar metals I've written, but different metals of different types can be bonded together. And there is one other very important aspect of this is that actually when we do friction welding, we are not melting the materials we're welding together. We are of course heating them, but we are not melting them. And that means that we don't really get the same type of problems you can get with warmer welding processes, such as cracks and pores and other problems. And as I already mentioned, the process itself requires no filler material, no fluxing, no shielding gases, and so further. So it's very effective, and no, as I already mentioned again, no pores, no cracks. The technology itself is very controllable, inline controllable. It's 100% repeatable. We can ensure that each welding is done in the exact same way. We can have an online, inline quality control as the weld happens. And that gives us also a full traceability down to single part traceability in terms of quality control of the weldings that are done. And of course, not the least, that friction welding is actually defined as a sustainable technology, as it requires no consumables, as I mentioned, and less energy than other welding technologies. So because of it has been defined as a sustainable technology, which is of course important to us all. Now, where is typically friction stir welding used? If we start off with friction stir welding, and when we at KUKA talk about friction stir welding, we do it with a robotic arm. We will get back to that later, but we do it with a robotic arm to get the advantages you get when you use a robot at all in any other process. But friction stir welding is mostly about joining metal sheets together, and in our case it's mainly aluminium and non-ferrous metals that we join together. So the typical area of use is very much into the electric vehicle application fields, the e-mobility areas. So housing of battery packs for vehicles of any kind is a very large part of the area of application. It can also be in body shops, for example, where joining metal sheets to the frame, typically aluminium to steel gauges and so on, because again, we have the possibility to join different types of materials. Heat exchanger or fuel cells are another area of application where we need very precise, very thin canals between two sheets of metal. And of course, again, the e-mobility field, which requires a lot of enclosures for the various electronic parts needed in our hybrid or electrical cars. Not only the battery needs to be capsuled, but also other electric components like the drives units, the electronic boxes, so on. And to the right, you see how simple a friction stir welding cell actually could look. If you look a little bit at the principle of friction stir welding, well, basically we are plunging what we call a probe down into the material. A probe that is rotating. That means that once we plunge the probe down into the material, and the probe itself is defined of two parts, basically, a shoulder, which is what we see, and what is smaller, and the part which sticks out, you can see it here, is called the pin. And there are two different techniques here. Either the complete shoulder and the pin can rotate, or just the pin, which gives us a little bit different quality aspects. But basically, we start plunging the pin into the material. We start rotating the pin to build up the frictional heat required. And so we stand still until that heat is the required temperature is reached. And once that is done, we start moving our probe in the required pattern we need to do the weld. Once that is done, of course, we then retract. At the end of our welding scene, we retract our probe. And typically, a weld will look something like this in the material. And of course, there is a number of process parameters and settings, such as axial force, tilt angle of the probe, traveling speed, offset, depth of the probe, side tilting, and so on. And KUKA can not only supply the equipment for this, but we also can supply the know-how, the expertise needed here. Likewise, it's important when we friction weld that the material is clamped together, that we have a fixturing that is really good to the materials. This is where our expertise comes into play. And we do have extensive experience in friction stir welding with either, as I mentioned before, classic tooling with both a rotating shoulder or just a rotating pin. And we have welded all types of aluminiums in alloys in different types of seams, as you see in the bottom picture here. So it could be a butt switch where we're replacing two edges towards one another, an overlapping weld, which we see in the middle picture here, to weld two materials together, or a combination of the two, as we see here, and butt and overlap joints. All these types of joints are possible to address with friction stir welding. So let me just show you a video of this, which describes it actually. And this is an example of a battery housing clamped and friction stir welded. I'll start the video. So I hope you saw the video. for the observant viewer, you could see a few things there. We're not just welding together two metal sheets, but the application in this case was actually sealing and creating cooling channels in the battery housing in this case. Thanks to our knowledge in friction stir welding, this has made us a really experienced supplier in the electric mobility area for assembly and manufacturing of battery packs for automotive battery packs. Because it's not just a question of putting batteries together in a box, but to make sure that the lifespan of these battery packs are as much long as possible. That means that they need to be cooled or heated depending on outside temperatures. And this is done through the housing and to a large extent. But I mentioned earlier that when it comes to friction stir welding, we use a 6-arm robot, which makes us pretty unique in the market if doing friction stir welding in this way. And the question is, of course, why do we use that and not a portal robot or a CNC machine? Well, the answer is quite simple. We do it for the same reason why we use robots in any other type of production. A robot always gives us a very high degree of flexibility and the ability to have short production cycle with a high volume of differentiated products. Of course, it also gives us the possibility to do a 2-dimensional friction weld, which we saw in the video earlier. But of course, since it's a 6-axis robot, we can do it in a 3D environment as well. We are not restricted to the 2D plane. And of course, it's a relatively simple solution, which makes it flexible and scalable. It's easy to scale up. And of course, a robot is comparative to a CNC rig or a portal robot, a relatively low cost investment. And obviously, we are a robot supplier again, where we have a large installed base, we have a global service team of this axis. So what can we supply then? Well, we have standardized cells for friction stir weldings, which we call cell for friction stir welding, FSW, in different sizes. They are modular. We can also sell friction stir welding as an application module, which is basically a robot with its control cabinet, a friction stir welding spindle, and then we would also supply expertise and know-how into the process. So we can do it as standard cells, we can supply the components, or if you like, we can also supply them as turnkey projects. And here are 2 interesting applications which has been done by KUKA. In one case with KUKA on its own, and other cases together with our partners in the market, our system partners. So you see, we can supply a wide range of applications, not only a standard cell, and most importantly, we will supply the knowledge required to ensure the quality of the process. If we now leave the topic of friction stir welding and look to the rotary friction welding, which is based on the same principle, but the application fields are a little bit different. In friction welding, there are typically 2 parts that are moved towards one another under pressure and then rotated so we get friction and build up the heat. This is easiest described again with a video, so I'll start a new video for you. This video pretty much describes how the process looks like. In the GoToWebinar panel, there is a field called handouts, if you have a look. And under this, I've uploaded a couple of PDFs, which describes these two processes and our standard friction welding machines. So if you're interested, please, you can download them from there, or you will of course find them on our webpage as well. But friction welding, rotor, which you saw here, is actually not a really new technology. That's been around for 50 years plus at the current stage, and we have more than 1,500 installations of these machines worldwide. And again, the interesting part here, well, one of the interesting parts is that different types of material can actually be welded together. And this example stuff you see here, it's everything from stainless steel to aluminum to copper and even titanium at the end. So here we have the possibility to join completely different materials, which could be important from a cost-saving perspective, for example. As a little bit extra knowledge, it's even possible actually to friction weld wood together. Of course, not to steel, but different types of wood can actually be friction welded together. Here is an example and a few examples of application fields where different types of materials have been welded together. So in this case, you see a connection plate, a cable lug, where you have a copper and aluminum combination. It's an aluminum cable or leader with a connective plate in copper. This is the turbo rotor shaft, where Inconel and steel has been bonded together. To make the complete shaft and fans in Inconel had been extremely more expensive than doing these combination of materials. Drive shafts with a combination of aluminum and steel. And as you know, this is also important parts in the e-mobility parts to make lightweight and flexible drive units. And actually, as I mentioned before, in this feed, KUKA acts as a machine builder. We have a wide program of friction welding machines, and they are sold under our own KUKA brand and also under the brand Thompson, which is a part of KUKA. And we have them for obviously different welding diameters, which also not only increases the size of the machine, but it increases the cross-section and the pressure that's needed during the welding process. And we have also a complete new generation of these machines, from the smaller ones to the larger ones, and both in horizontal orientation and in the vertical orientation. And these machines are not sold only as machines, if you like. It's quite possible that you need an automated material handling around the machine, which could be either supplied by us or one of our local system partners. This is a close-up of one of the KUKA rotary welding machines, which is really ergonomic, ease of use machine. You have a process surveillance, a graphical process monitoring. That means that the quality of the weld is actually monitored in real time, and you can ensure that each piece is welded correctly. It is prepared to exist in an Industry 4.0 environment. What that means is anyone's guess or anyone's interpretation, but what it actually means is that it is connectable. We can supply and receive information from other machines, higher level machines, put out production statistics and so on, directly from the machine. And of course, as I mentioned in the beginning, we are the world leader in these welding technologies. And these are the common states. But we do not only supply the components and the parts. We supply the systems which ensure that these welds, whether it's friction weld or friction stir welds, that each single weld is up to the quality spec. We do that in real time and inline. So if there is a problem, we can immediately discard that unit. And of course, during today's webinar, I've mainly talked about the machines and the solutions. But of course, we are there to assist you. And you will not just run away to buy a machine immediately. In each case, we are there for the process consulting, to make a proof of concept, to recommend what type of technology we should use for your. We can do test runs in our own facilities before you start your productions. We supply the machine, we can supply the automation around, either directly from us or through our partners. And afterwards, we have a worldwide service organization taking care of you as our customers. And with that, we have basically come to the end of today's webinars on the topic of friction stir welding and rotary friction welding. We actually have a few more technologies for these solid state welding solutions, but I will leave that to another webinar opportunity. That means that we are more or less to an end of today's webinar, which was meant to increase the awareness and hopefully wake some interest in our solutions with you.
Industrial intelligence.